In this video, we're going to look at writing equations of lines based on a description of whether or not the line passes through 1 point with a given slope or 2 points with no slope given. And this will help you with part 2 of your analyzing lines homework. And refer to this video and the previous one as much as you need to. Just remember, in the previous video, we were concentrating more on the slope of a line and how to find the slope of a line. In this video, we're going to actually be looking at using slope and a point given to write the equation of a line. One of the most common forms of writing a linear equation is slope-intercept form, y equals mx plus b, where m represents your slope, b represents your y-intercept. Now carefully note the format. It's y isolated, y equals. In the previous video we did at least one example where the y wasn't isolated. And so if that's ever the case, you can always isolate y using appropriate solving techniques. And once y is isolated, the x term contains your slope, the constant is your y-intercept. We're also going to look at the second formula at the bottom half of the page where it's point slope form. This one's a little bit different. This is if you're given slope and then just some random point that is or is not on the y-axis. If you know the points on the y-axis, use the top formula, plug in your slope and your intercept. If you're not given a point on the y-axis, then you'll need to use the bottom one. M's still going to be your slope, but the point given that's not on the y-axis, denoted with an x1, y1, it has its appropriate places to plug in. So what we're going to do is a series of problems where we'll have various descriptions of lines given, and we're going to write the equation of that line described in slope-intercept form. That's the y equals mx plus b. In this first example, we have a slope given, and the point 0, -5, if you think about its location, it is on the y-axis. Therefore, we can jump right into point slope form, slope-intercept form, and we can just plug these two numbers in. Slope is given, and y-intercept is given. I'm going to go ahead and graph this one just as a refresher on graphing lines. Now let's remember, when we're graphing lines, we want to mark off the y-intercept first. We're going to go all the way down to -5. Put our dot there. We'll go ahead and label this. Okay, what was our slope? +2. 2 as a fraction is what? 2 over 1. Up 2 over 1. And that takes us to the point 1, -3. From here, all we have to do is connect these two dots, and we've got the graph of our line. Now, even though we weren't asked to graph, it's good practice, and a lot of problems on your homework set are going to go ahead and ask you to graph even after you found the equation of the line. But just as a refresher, that's how you do it with slope and y-intercept. Plot your y-intercept, and then use your slope to get to a second location. And once you're there, connect the dots. On the second example, we're given a slope of -2/3, and the line should pass through the point 3,7. Now this point 3,7 is not directly located on the y-axis, so we can't use the y equals mx plus b equation, but we have that point slope form that we can use as a backup. Let's remember that one. Y minus y1 is equal to m times x minus x1. M is the slope that's given, and x1, y1 is going to be replaced by the two values in the ordered pair. Y minus 7 equals negative 2/3 times x minus 3. Distributing the negative 2/3, that's going to give us negative 2/3 x. Be very cautious here. On the second jump, negative 2/3 times negative 3 is positive 6/3. Think of that 3 in the parentheses as being over 1. So that's positive 6/3, which reduces to 2. Add 7 to both sides, and you're going to get negative 2/3 x plus 9. Alright, so that is the slope-intercept form of the line described at the top of the page. If we were to graph, we would need to plot our 9 on the y-axis first. And then, and let's do that. I'm going to zoom in a little bit. Alright, so I'm going to go ahead and call that 0, 9. The slope is negative 2/3. So what we're going to do is from that intercept, we're going to count down 2 over 3, which that's going to take us to 3, 7 if you were to plot this point. 1, 2, 3. 3, 7. Connect the dots. It has a negative slope, but not very steep, and that's one of the features of a slope of negative 2/3 is it is negative, so it's going to run down and right, but it isn't very steep at all. And I'm going to put a 0 here for origin. On our third example, we're given 2 points that a line passes through. We are not given the slope on this one, so that's the first thing that we'll find. Recall our slope formula is y2 minus y1 over x2 minus x1. For these set of points, that is negative 2 minus 5 over 3 minus negative 1. So that's negative 7 over 4, and that's the slope of this line. Now with the point slope formula, you can use the slope of a line and any singular point that it passes through. So you can pick either one of the 2 points in the beginning. I'm just randomly picking the first one, and I'm going to use that and the slope we just found. And so using point slope formula, that is y minus 5 equals negative 7/4 times x minus negative 1. Distributing negative 7/4, we get y minus 5 equals negative 7/4. Well, we're going to distribute on the next step. I'm going to go ahead and clean these two negatives up. Write that as x plus 1. Now we're going to distribute the negative 7/4. So that gives us y minus 5 equals negative 7/4 x minus 7/4. Adding 5 to both sides. Now let me show you a little trick here. Adding 5, common denominator. That's going to give us y equals negative 7/4 x. common denominator allows us to add the numerators. Negative 7 plus 20 is 13 fourths.